Today let's try to solve another Leetcode problem. 857 minimum cost to hire K workers. So we are giving n workers. So n is the length of the quality array or the width array. And there are two integer arrays with quality and width. And quality I is the quality of the ith worker, and width I is the minimum width expectation for the ith worker. So this might be difficult to understand. Yeah, so this width I, so for example this 70, it is just a minimum width expectation. So it is just a minimum value. It's not the real value. Yeah, let's just use an example. So yeah, for example, if we choose the first worker, so the quality is 10 and we get a width of 70, right? Yeah. Now we are going to minimize the final result, and there will be exactly K workers. So we have to choose another worker. We need to decide which one to choose. Yeah. So what about the ratio? Currently the ratio is 70 minus 10. So I'm gonna use the width divided by quality to get the ratio, because I will be pay the employees according to the ratio. So currently the ratio is 70 divided by 10, it is 7. So I'm gonna choose the third person. So for the third person, the quality is 5, but the expectation is 30. Yeah, but the ratio is 7. So it means 5 times 7, it must be larger than this 30. So I'm gonna choose 35. So this is gonna be the final result. It will be 70 plus 35, 105. Yeah, I hope you understand this problem. Let me just give you another example. Still, we're gonna choose the first person. And next, we're gonna choose the second person. What is it gonna be? Yeah, because we choose the, let me just copy the array. I think it should be more clear if I put it here. Yeah, otherwise you may not understand. So, the first array gonna be the quality, and the second array gonna be the width. So if we still choose the first person, so the ratio is still 7 at the moment. Let me put the ratio inside. So the ratio is still 7 at the moment. And if we need to choose another person because K is 2. So if we choose the second person, not the third. Yeah, I've already analyzed the third. If I choose the third person, I got 105. Yeah, now if I choose the second person, because the ratio is fixed, it is 7. So for the second person, what is the quality? The quality is 20. So this means the maximum value should be 20, this quality, times 7. It is 140. So it is 140 plus this is 70. It would be much bigger. As you can see, it is 210, but 105 is the minimum. Actually, we just need to calculate the minimum value. So how should we calculate it? Yeah, if you understand the ratio correctly, you should at least find a way to solve the problem. Even maybe you didn't solve it because you didn't know about this kind of a pattern, or maybe your coding skills is not enough to support you to solving this kind of a problem. But actually, if you already understand the ratio, so the ratio means we need to choose some employee as a reference. So for example, if we choose the first employee as a reference, so for the other employees, it must meet this kind of a ratio. And after that, the final result would always be bigger than this 50 and 30. Yeah, otherwise you will get wrong. So this means we need to find the, so what kind of a ratio we can choose, from smaller or from bigger? Yeah, so this means if we choose a bigger ratio, for example, this ratio for the first employee, it is 7. If we choose 7, it always meets the other conditions, because the second ratio, as you can see from here, it is 2.5, and the third ratio is just 6. So yeah, why not? We just choose the maximum ratio. If we choose the maximum ratio, it means this person, if the first person as a reference, so all other persons already meet the conditions. Yeah. Now, if we find the ratio, we can sort out this ratio according to the increasing order. why it is increasing order, not decreasing. So this is the trick. If you use in decrease order, you cannot solve the problem. Yeah. So if we use the increasing order, yeah, let me put the two values as a tuple inside. So the two values currently, the quality and 10 and the width 70, and the ratio is 2 and the ratio is 7, right? Yeah, so I'm gonna put it here. And for this 2.5, let me just copy it. Yeah, so for the 2.5, it is 20 and 50. So this is 20 and this is 50. This is for 2.5. And the second one, it is 6. Yeah, so for the 6, it is 5 and 30. So here I gonna put a 5, and here I'm gonna put a 30. So this is the last one. So I'm gonna sort the ratio according to the increasing order. Yeah, this is really important to solve this problem. Yeah, if I sort it in increasing order, this means if I choose a ratio of 2.5, this means this element, the first element, the first person must meet the condition because the ratio is 2.5. But for all others, I didn't put it inside the array. It is still okay. Yeah. Now, secondly, I want to put the second person inside my result. So currently the ratio is 6. If this 6 meets the conditions, so it means this 2.5 must meet the conditions. So this is why we need to analyze this kind of problem. It is a greedy problem, but there's patterns. So the patterns is called sort plus priority queue. Yeah. And this priority queue can be a min heap or can be a max heap. It depends on the problem. And for our problem, we're gonna calculate the minimum value. Yeah, because we're gonna get the minimum result. So we're gonna use the max heap. Yeah. Yeah, we use the max heap because if we put some value inside our result. So for example, the first one, what kind of values will be put inside our max heap? So first of all, we have this 20 and 50. So what is the quality? So definitely we're gonna put 20 inside our priority queue. Here I'm gonna prepare a PQ. So I'm gonna put 20 inside my priority queue. And I used a ratio of 2.5. Yeah, but I need to keep 2 person, not 1, because I need to get exactly k person. And secondly, I can choose the second one. Yeah, if I choose the second one, what the ratio gonna be? The ratio gonna be 6, not 2.5. If I use the ratio of 6, it means this 2.5 must meet the condition. Let's just check it. So for the second one, I want to put this 5 inside my priority queue because this is the quality of this second person. And I need to check. So the length of the priority queue is 2. It means I've already found 2 person. Yeah. So this what about this ratio is 6? Yeah. So if the ratio is 6, it means I can use 6 as my reference. So 20 times 6, it is 120, and then plus 5 times 6, it is 30. So the final result would be 150. Yeah. Now we have 2 person, and our result is 150. Yeah. I'm not sure if you understand it. I mean, I prepare a max heap. So the first element inside the quality is 20, and secondly, I have a 5. So I need to sum up the element, 2 element. It is 25. 25 times my ratio 6. So yeah, why I use it like this? Because 6 times 20 would always be bigger than 50. Yeah, this is the trick. Yeah, this is 6 times this 20 would always be bigger because I've used a bigger ratio. If I use a bigger ratio, it would always be bigger than the smaller ratio because smaller ratio is only 2.5. Yeah. Now I need to check the third person. I would put the third person inside my priority queue. So I'm gonna put 10 inside my priority queue. And what is my ratio? It is 7. So what is my result? I need to pop out the maximum value because I don't need this 20 anymore. Why? Because I only need to have 2 person. So I will pop out the maximum value. Now it would be 15 times 7, so the final result would be 105. So I'm gonna choose the minimum value, 105. So this is gonna be my final result. Yeah, I hope you understand all about that. If you don't understand that, you can check my GitHub. I've already committed the solution. So this kind of a template, I call it sort and priority queue. Sort plus priority queue. There are 3 similar problems exactly like that, and this one gonna be the most difficult ones. Yeah, because this is not so easy to recognize, and it's not so easy to understand the problem. I mean, yeah. I mean, it's difficult to read the problem, to understand the problem, because it just the description just makes the problem really difficult. But actually, it is if you understand the description, it should be easy. Now let's just start coding. Yeah. So I will prepare a result and a total and a PQ. So the result would be starting from 0, and the total is the sum of the quality values, and the PQ would be an empty array. Now I'm just want to loop through the quality, and yeah, let me just do some preparations. Yeah, I want to do some preparations. Let me prepare nums. Yeah, because I want to put all the possible results inside an empty array nums. So let me do check this quality and weights. Yeah, so for Q, W in zip, quality and weights. Yeah, why? Because I need to get a ratio. I would want to put the first element inside nums with a ratio. So this ratio would be W divided by Q as my ratio, and the secondly I gonna get the quality and weights. Yeah. So this is just some preparations for the array nums. Yeah. So if I get this ratio, I want to sort it in increasing order. Yeah, as you can see from here, I want to keep it in increasing order to solve the problems. So nums dot sort according to this ratio. So this is just some preparations for the nums array. Yeah, so I put the ratio, quality, and weights inside the array nums. Yeah. Now I'm going to check this array. So for R, Q, and W inside my array, so inside nums. So what is gonna be the possible result? So let me just use a total should plus to this quality, and the result might be the maximum of the result with my current yeah. So what is my current ratio? It is R, and what is the total value? It means the total quality inside the nums inside the array quality. So it would be R times total. Yeah. And what are going to be the conditions? It must be the priority queue if the length of the PQ equal to K. So I gonna check the result. Yeah. And finally, I got to the result. But this is not the end. I didn't put anything inside my priority queue. So I needed to use a heap push. Inside of the priority queue, I needed to push the, yeah, let me check the quality inside. Yeah, but as it is a max heap, I need to push a negative value, and then I turn this min heap to max heap, because in Python there's no max heap. Yeah. Now I prepared the max heap, and I have to check the length of the PQ. If it is more than K, I need to pop it out, and I need to pop out the maximum element. Here I use MX. It's gonna be the maximum element. It's gonna be the heap pop of the PQ. Yeah, because it is a negative value, I need to use another negative sign. Now it is positive. So the total should be minus this maximum value. Now I've already kept my total exactly like this, 5 and 10, because I've already popped 20 out of the priority queue. And if the length equal to k, I will check my result. And finally, I just need to return the result. Yeah, because the accuracy is 10 to the power of minus 5. For Python, we don't need to do that. Now let me just check if it works. There are mistakes. I don't know why. Yeah, I got 150. It should be 105. Yeah, I did some mistake. Let me just have a check. Yeah, let me just check the nums first. Yeah, I need to make sure that the nums should be sorted in increasing order. Yeah, I think it should be in increasing order. Yeah, it is right. 2.5 with 20, 50, 6.5 with 5, 30, 10, 70. It means here is right. Yeah. Now, yeah, because I want to get the minimum value, so this is something wrong. I need to check the minimum value, and this result should be the infinity. Yeah, I think it is coming from here. Now let me run it. As you can see, it works. Now let me delete the print and submit it to check if it can pass all the testing cases. As you can see, it's pretty fast and it passed all the testing cases. And the time complexity, let's just check, n is 10 to the power of 4. And normally for such kind of problem, the time complexity is always n log n plus n log k. Yeah, because we just need to sort the array first. This is n log n, and here we use the priority queue. It is n log k. So this is gonna be the final time complexity. And this pattern, I think, it's gonna be most of the cases. It's gonna be the Leetcode in the weekly test. It's gonna be the third or the fourth problem. Most of the time, it may be the fourth problem. But actually, if you understand this greedy idea or the priority queue, if you can recognize this kind of a pattern, normally you can solve the problem. But you need to practice. So as I recommended from here, you can check my GitHub and try to practice these 3 problems because they are exactly the same. So the minimum performance of a team, or minimum cost to hire key workers, and maximum subsequence score. If you read the title,